let us see the process of inserting an item at a given position in one-dimensional array. Let us see the algorithm first, and later we see the program. Insertion of an item at the given position, in one-dimensional array. What do you mean by this? Suppose an array contains 5 items. 1, 2, 3, 4 like this. Suppose 10, 70, 30, 40 and 80. Array contains 5 items. Inserting a new item at the given position. Index is 0, 1, 2, 3 and 4. Last index is n minus 1, 4. Suppose the new element is equal to 100 is inserted and the position is equal to 2. What do you mean by this? At the position 2 means index 2, you have to insert the new item 100. Already at index 2 there is one item 30. And what should be done for this? How to insert? When we insert one item into an array, the number of items becomes one more, correct? If there are n items, the number of items becomes n plus 1. How to insert here? Whether it is overwritten? No. The available items, already existing items, must be shifted towards the higher order locations in the memory, correct? That means when the item 100 is assigned to the index position 2, the already available item 30 has to be shifted to the new location here, the next location. Already there is one item 40, it has to be shifted to the next location. And the item 80 there has to be into the new location, correct? Thus number of items becomes 6 there. But closely look at this. When you shift this one, when you assign this one to the higher location, the 40 is overwritten. Or if you start with just assigning 100 to the index 2, the already existing item 30 will be overwritten. So for the next assignment it is not available. So even then, when you assign 30 to the next position where 40 is there, 40 is overwritten by 30. So 40 is not available there, so that it can be copied to the next location. So if you start shifting the items, I mean assigning the items from this given position towards the higher, it may overwrite the values. So if they are overwritten, these are not available for the next copy. So values are totally gone from the array. So this should not happen. For that, the shifting operation to the higher order must start from the last item of the array. What is that? So first shift 80 to the next higher location. Start shifting not from the given position but from the last position of the array. 80 copy to the next location. So here comes 80. Here also 80 at present. Copy the previous value to the next. So copy 40 to the next index 4. So the value at index 3, 40 is copied there. So 80 goes and 40 comes here. Right? So here 40, copy the previous value. Right? So 40 goes and 30 comes here. Now here also 30. Now assign the new value to be inserted 100 at this location P. Right? P is 2 here. So this goes and 100. So you observed here, when you start shifting by copying the values from the last position to the new, it's previous to the last, it's previous to the next position, right? So this shifting operation must start from the last number. If you start from the same index given here, position, it may overwrite the values, correct? So that is why this shifting of items is taken care of by a downward loop. For loop we take usually. It is a downward loop starting from the index n minus 1. So the item at n minus 1 has to be shifted to the next location n. So far there is no index n because n is the number of items. Index n is not there. Last index available is n minus 1. So shift the item at index n minus 1 to index n. Index n minus 2 to index n minus 1. So in general, index I plus 1 should be is equal to index item at the index I. So A of I plus 1 is equal to A of I, its previous item. For any index 3, the item at 2 must be assigned. For index 4, item at 3 must be assigned. So that should happen from end down the loop till the given position. Correct? So the for loop is from n minus 1 down to p. So shifting operation is taken care of by the statement A of I is I plus 1 is equal to A of I. Correct? Hope you understood this. And next, the number of items becomes 1 more. N is equal to n plus 1. Let us write the algorithm for this. So the algorithm is a very simple algorithm. Step 1. For I is equal to n minus 1 down to p, where p is the position to insert. A of I plus 1 is equal to A of I. So this statement will take care of shifting the items to the higher order locations. And 4. And 4. So next, step 2. Assign the element new item to the position A of P. A of P is equal to element. The new element or item to be inserted. Assigned to the position. Next, since you have increased the number of items, show that n is equal to n plus 1. Number of items, when you add 1, becomes n plus 1. That's all. Step 4. And so that's a very simple algorithm to shift. Shifting involves, inserting involves shifting of items. As I told, it's a downward loop from last item till the given position. And shifting is done using this statement. Copying, assigning the previous item to the next location. Previous item to the next location. I plus 1 is equal to I. Assignment is always right to left. And 4. So all the items will be shifted, and at that position, given position P, we assign the new element which we have entered. That's all. Number of items should be 1 more. Correct? Okay. Now after this, I will write the program. Even we can also write the program to enter, insert a new item. Now here itself, I will discuss the algorithm to delete an item. Algorithm to delete an item. Delete from the position. Let us see the algorithm. Before the algorithm, let me explain how deletion is done. So when you have the array like this, 10, 20, 30, 40, and 50. So it is A of, suppose 5. Enter the position to delete. So in the case of deletion, we indicate at which location. Right? Suppose position is equal to 2. So 0, 1, 2, 3, 4. When we delete one item from any given position, what happens to the number of items in the array? Number of items becomes 1 less. Correct? We decrease the number of items. So n becomes n minus 1. Correct? What is the logic of deletion? Here also we shift elements. So for example, the item at index 2 is 30 has to be deleted. Means the numbers or elements in the higher order than the given position must be shifted down, correct? Towards the lower memory locations. 40 has to be shifted to 30. So 30 is overwritten by 40. And 50 has to be assigned to the lower. So it is a very simple statement. But before you do this shifting operation, we can assign, we can store the value at the given position so that we can display it if required, because after the shifting operation the value is not available. So in case you have to display which is the item deleted from that position, we store it in a given variable. So I will write the algorithm. Shifting happens like this. Given position 2, starting from this one, starting from the index 2. So this has to be deleted. Means, so you write a of I is equal to a of I plus 1. A of 2 is equal to a of 2 plus 1. So this will be overwritten. So it becomes 40. And 40 is overwritten by 50. And 50 totally we don't refer. Number of items becomes n minus 1. So there are only 4 items. This index is out of reference. So note here, when you are taking an array, number of items becomes 1 less. So when you display the array elements after the deletion, the number becomes 1 less. So that means the last index you don't refer to. If there are 5 items, the last index is 4. When you delete 1, last index becomes 3. So 4th index is not at all reference. So that's it. So I will write the algorithm now for this. So first we can store this item. Suppose element is equal to a of p. The given item at the given position is assigned into a variable so that we can display it, which is the deleted item. So next step 2. For I is equal to p to n minus 1. It is an upward loop starting from the given location p. Right? So a of I is equal to a of I plus 1. A of I is equal to a of I plus 1. Shifting the higher order elements to the previous. So I plus 1 is assigned to the previous location. And 4. So next step 3. N is equal to n minus 1. Step 4. You can display, print the deleted item. That also you can do this. That is all, right? So this takes care of shifting the items from the higher order to the previous each time, starting from the given index. So I hope you have understood this, and in the next section we write the program for this.